Tonight, let's talk about the aircraft carrier in Dalian, which is the nuclear-powered aircraft carrier. Previously, because of the Wuhan Carrier Land-Based Test Facility, often called the Wuhan Aircraft Carrier Test Building, it had something resembling a smokestack. Then, not long after, a model appeared. This model could clearly be seen as a conventionally powered aircraft carrier. So, many people asked, is the aircraft carrier built by Dalian conventionally powered? Later, new photos were exposed online, suggesting that the conventionally powered aircraft carrier being built by Jiangnan Shipyard might be the one related to the Wuhan Carrier Test Building concept of a single island superstructure serving two purposes, able to test both conventional and nuclear power. But first, let me state clearly, the one Dalian is building is definitely nuclear powered. Now, it's widely rumored that Jiangnan Shipyard will also build a conventionally powered aircraft carrier, most likely an improved version of the Type 003, meaning an improved version of the Fujian aircraft carrier. So, will a conventionally powered aircraft carrier built by Jiangnan Shipyard show improvements in its island superstructure compared to the Fujian? This is something we need to wait and see. Moreover, we can also see that the position of this island is basically unchanged compared to the Fujian. It's no. Two catapults still intrudes into the angled flight deck. The aircraft parking and preparation area in front of the island is still insufficient. So, personally, I think the modifications to this island are not very significant. Therefore, most likely, the island of the new conventionally powered carrier from Jiangnan Shipyard will not differ greatly from the Fujian's island. Any changes will be minimal at most. Now, let's talk about the latest exposure. Later, the online community generally confirmed that the Dalian shipbuilding industry's vessel is a nuclear-powered aircraft carrier. A key piece of evidence was the exposure of a hull section picture. From this picture of the section, we can clearly see that the nuclear reactor shielding seems to have been installed. Currently, it appears that the nuclear-powered aircraft carrier built by Dalian, similar to the US Nimitz class and Ford class, also has two reactors. If we look at the construction photos of the US Ford class, we can see here, this is its nuclear reactor shielding being built. These two are the installation bases for its steam turbines. In this photo, the Ford class's two nuclear reactors have already been installed, and its 4 steam turbines have also been installed. As for our country's conventional powered carriers, like the Liaoning, Shandong, and Fujian, their structure originates from the Soviet Kuznetsov class, specifically the Project 1143.5 design. Their structure involves having boilers behind the steam turbines. Therefore, Dalian's hull section clearly shows its structure. After installing the nuclear reactor shielding, based on its position, though I don't know currently if this section is from the bow or stern, we can see that there is no space behind it to install 4 boilers or 2 steam turbines. So, it can be completely determined by comparing Dalian's new hull section with the construction process of the US Ford class carrier, that Dalian shipbuilding industry is building a nuclear-powered aircraft carrier. Some people ask, can't the island be moved aft on a conventionally powered ship? Actually, there are ways. Let's look at history. At the Japanese aircraft carrier Kaga from World War II, we can see its smokestack was placed relatively far aft. If they had pulled the smokestack piping even further back, placing it more aft wouldn't have been a big problem either. From this, we can see that a steam turbine already requires such a large pipe, which occupies a lot of internal space on the warship. If it's a gas turbine, the air required by the gas turbine, since gas turbines primarily work by combusting air, means that although the exhaust pipes can be routed aft, the internal space occupation for intake and machinery still remains. Take Japan's Izumo class. To increase deck area, they placed the gas turbine air intakes on the sides of the hull. Although this reduced the deck area occupied, the internal space was still occupied as needed. So, if a conventional power plant's island is to be placed aft, the internal space must sacrifice a large amount of room for the gas turbines or the steam power plant's smokestack piping. So of course, there's no way to avoid sacrificing space. The biggest advantage of integrated electric propulsion is that the main engines don't need to be connected directly to the propeller shafts. This makes layout much more flexible. For example, placing the prime movers above the waterline, like the UK's Queen Elizabeth class, which placed its 2 gas turbines on the sides of the hull. This way, relatively speaking, the space occupied by the exhaust ducts within the hull is greatly reduced. However, this creates a major problem. Placing gas turbines above the waterline makes them vulnerable to attack in battle, easily causing the ship to lose power. Countries like China and the US would not follow the UK's approach of placing prime movers above the waterline, especially on the hull side. If placed amidships, it would greatly affect the aircraft carrier's hangar space. So this is also impossible. Then some people ask, could it be a combined nuclear and conventional power plant, CONAS, citing the presence of a smokestack? Actually, a combined nuclear conventional system is very unrealistic. The so-called combined system usually means using nuclear power for cruising and gas turbines for boost acceleration. But this is quite unrealistic, because for a warship, increasing speed by each knot requires a geometrically increasing amount of power. It's not a linear relationship where the horsepower required increases by the same percentage as the speed increase. For example, Japan's World War II Yamato class had a full load displacement of 73,000 tons, and its power was only 150,000 horsepower. But the much smaller Iowa class, the Iowa class had a very large length to beam ratio for a battleship, about 1:8 compared to Yamato's roughly 1:6. Something, with a full load displacement of 55,000 tons, required 210,000 horsepower to achieve 33 knots. So, if a 73,000-ton Yamato class were to increase speed from 27 knots to, say, 30 knots, not even 33 knots, it would need over 200,000 horsepower, meaning its power would need to increase by at least 50%. Coming back to the aircraft carrier being built in Dalian, even if it's built smaller, its size won't be less than the Fujian. If the Fujian is about 80,000 tons, to achieve over 30 knots, you would need at least 240,000 horsepower. If half of that is for cruise power nuclear, that's about 120,000 horsepower. Then using 4 gas turbines for boost power would make the exhaust duct design extremely complex. Furthermore, you wouldn't need a small number of gas turbines. Japan's Izumo class has 4 gas turbines, just 4 LM2500S. So, suggesting this kind of combined system shows a lack of confidence in domestic nuclear power technology. Some people say, didn't the Soviet Union develop combined nuclear conventional power? The Soviet Kirov-class nuclear-powered battlecruiser was not a true combined system, in the sense discussed. That was because Soviet nuclear reactor technology at the time was not as good as the US's. Their reactors had a relatively high failure rate. The Soviet system was actually an alternate power system. When using nuclear power, it could only use nuclear power. When using conventional power, it could only use conventional power. This was a Soviet design for the Kirov class. In case the nuclear reactor failed during ocean operations, it could use the conventional power to return home. The conventional power was not intended to boost the Kirov's speed. Its power was relatively small, enough for a speed of over 10 knots to get back home. So, its conventional power output was comparatively small. Our country would not adopt such a so-called mixed nuclear conventional power system like the Soviets did. Rather than that, it would be simpler to just use conventional power altogether. Why use nuclear power then? Furthermore, many people ask whether building a nuclear-powered aircraft carrier requires first building a surface test ship, like an icebreaker or other vessel type, to install and operate the reactor. Actually, this is not necessary. For nuclear reactors, conducting long-term tests on land is sufficient. It's not absolutely necessary to install it on a surface ship for testing. We have seen a photo here. It's a bit old, from around 2020. Although the text is blurry, one can still make out a bit. It mentioned testing for large surface nuclear power boilers had already started then. It has now been tested for 5 years, including 2020, so at least 6 years. This 6-year period is enough. Look at the US nuclear-powered aircraft carriers. When they were built, they did not build special surface test ships. The reason the Soviet Union built so many surface nuclear-powered ships was not primarily for testing nuclear carriers. Actually, it was because the Soviet Union originally planned to build nuclear-powered aircraft carriers. But these plans were vetoed by the high-level leadership. The reactors that had been built had nowhere to go, so they were repurposed into ships like icebreakers or research vessels. Therefore, the aircraft carrier built by Dalian is 100% nuclear-powered. As for whether it will be called Type 004, that depends specifically on the hull type. The designations 001, 002, 003 for aircraft carriers are not simply serial numbers. They actually refer to the specific type or class of the carrier, just like the Type 055 for destroyers is a specific class. Similarly, 001, 002, 003 for aircraft carriers are type designations, not sequential numbers. Previously, our country's first aircraft carrier, the Liaoning, was acquired from Ukraine, an unfinished aircraft carrier that was refitted. The original Soviet design for their carriers included extensive arrangements for anti-ship missiles, including structural features to accommodate them. By the time of the Shandong, these were completely removed. Also, some unreasonable designs found on the Soviet carrier after we used the Liaoning were improved upon in the Shandong. So, although the Shandong looks very similar to the Liaoning, its hull structure actually has considerable changes. Therefore, the Shandong was given the new type designation 002. The Type 003 Fujian structure is obviously very different from the previous Shandong and Liaoning. Therefore, if Jiangnan Shipyard builds another aircraft carrier and its hull structure does not differ significantly from the Fujian, it would not receive a new type designation. The one built by Dalian, I personally estimate, will most likely be called Type 004.